All right, example 1, we're going to identify rigid motions. Are the following transformations rigid motions? Explain. So in our vocab or our intro video, we defined rigid motion as a transformation that preserves length and angle measure. So here's our first transformation right here. The pre-image is like the before. Maybe we'll just make a note. Before the transformation, and the image is considered the after. So when we see that vocab pre-image image, pre-image is our shape before any transformations have happened, and the image is the shape after a transformation. Okay, so here's our pre-image, whatever this random shape is. Here's the image. Is this a rigid motion? So what I notice is the angle measures, just by appearance, seem to be the same size angles. Those don't seem to have changed. But what has changed is the length of our side. So this length got smaller. This length got smaller. These lengths all got smaller. A rigid motion will preserve the length, which means the length will not change and the angle measure will not change. Because we had a change in our length, this is not a rigid motion. Not motion. Yeah, motion. Sounded weird for a second. So not a rigid motion. All right, our next example. Here we have our pre-image, the before, and our image, our after. It looks like it was rotated around a little bit, so we can see a transformation happened, but what we're checking for are the angle measures and the side lengths. Did we have any change in the length and angle measure? So here is one side. I can find its matching side over here. Those appear to be the same. This side right here is matching up with this side over here, appears to be the same. This and this side appear to be the same, and then these slanted ones appear to be the same. So it looks like our length was preserved, it did not change. And then angle measures, if you do a quick check on your angle measures, did it seem like there were any changes in those? And there were not. So this is what rigid motion looks like. So is this transformation rigid motion? Yes, we have rigid motion on this one. All right, so our last transformation, here's our before pre-image, here's our after image. Clearly they are not the same size. When they are not the same size at all, that means that the length was not preserved. I can see that this side matches up with this side, and in the pre-image it was smaller, it got bigger in the image. The angle measures, however, do appear to be the same, but a rigid motion will preserve the length and the angle measure. So since the length changed on this one, this is not a rigid motion.